Hey guys, update on my small scale bowling project. I told everyone that I would give them some updates as development went along, and I made a good bit of progress today on the automatic scoring section of this project. So before I get started, I'd really like to thank everybody on the Boltec forums and YouTube and everybody who's really just been a help to this project. It's been great, and Andy and Steve, JT66, everybody who has really just helped and dove in and given me specs and kind of some of the headaches that they've went through and kind of pitfalls and things to avoid. I really do appreciate it, and your advice is definitely working its way in. So what you're looking at here, though, is the 5-foot prototype section that I used. I just built it, I kind of threw it together in a day using 2x6s and 2x8s, much like Steve had outlined, and with a 2x10 bedding. The top is sandy ply, so I haven't really been doing a ton of rolling on this particular platform because of its abrasiveness, and I don't want to cause a bunch of strain on the pins and balls just yet, before I really start developing the machinery and that kind of stuff. So it's just a little 5-foot section I've put together just to develop the scoring. So aside from that, up on the top here we have an old Logitech QuickCam Pro, or QuickCam Express actually. It's a Logitech QuickCam Express. It was 30 bucks new about 9 years ago, and I've had it for that long, and it's just not a great camera, but it gets the job done. We have a fluorescent light fixture and just the very basic elements here. Computer just running Windows XP, and the software, as we can see, is written in Python. And Python, the reason why I chose that, and a lot of people may scoff at me because I'm a .NET guy actually for my job, but Python, it's lightweight, it's cross-platform. I mean, you could practically run it on your toaster, and I think that for those that may want to use this and tweak it or whatnot, it's a good language to even learn on. It's very simple. So, and I figured out I can do a lot. A little code goes a long way in this language. So, all the camera stuff and everything like that, it's all Python. So there's no special tricks or libraries or anything like that. Other than Python and Pygame and a couple imaging libraries that are the basics for Pygame that just allow it to interface with a webcam, but it's all Python code. So let's see. In order for this to score, just a little bit about it. In order for it to score, in the final product, we'll have an infrared crossbeam right here that will trip it, and it'll wait about 3 seconds and score. I believe 3 seconds is a standard, and if I'm wrong, please, forum guys, correct me. I hope you do, so, because I know you know. But there will be an infrared score, or an infrared crossbeam right here that will trigger the software to wait 3 seconds and then score the deck, and that'll give the rake arm time to come down and things to settle down. So that all just works, should work quite well. And I'll talk about that in just a second, actually. Let's see. So if we go through right now, and I take a couple pins off the deck. Here, I'll take 2. So we take a couple pins off the deck, and if you leave that combination, then you're doing something wrong. But anyway, and we hit S. S will simulate kind of that score infrared sensor there tripping. So if we hit S, it scores a 2. And if we hit S again, it scores a miss because it didn't sense any pin change or anything like that. Very, very nice. So let's take a couple more off here. We'll take a couple more off, and the deck looks even uglier now. Take a couple of them off and hit S again. Now it scored 4. So the system knows that how many pins you've hit, and the reason why or how we're getting that information is the camera is constantly taking snapshots, but whenever you hit that S, it analyzes the current snapshot. And that analysis is basically, it only takes the whites out of the image. And everything else that is not within a threshold of white is blacked out. So we got a nice contrast, a nice profile image of the pin deck from wherever the camera's mounted. So it works pretty well. Now, one thing that I can show you, though, is if we go, we'll just hit spacebar, and that'll take us into the menu of the system here. And we go to Advanced, and we say Calibrate Score Camera, for lack of a better term, I guess. What we see here is a current state of the pin deck. And that is basically what we're using. You'll see the little squares here, and what they represent are pretty much the scanning areas of the camera. And as you'll notice, it's a black and white image. And there are a couple things that I could do to improve that, like software smoothing and things like that. But it's a black and white image, and for the most part we scan the heads of the pins, but in some where it's tight we may be scanning the bases, and that all just has to do with mounting angle. That'll be refined over time. But all we do is we just we can click on the screen, anywhere on the screen, and add these little squares here. And these squares, whenever they're white, they count as a standing pin, and whenever they're black, they count as a fallen pin. They count as one pin fall. So with as this develops, there are a couple of things that you can actually modify. You can modify the thresholding and things like that. So if your lighting conditions are a little bit dimmer, a little bit brighter, you can adjust kind of the whiteness threshold, if you will, to where colors get blacked out, and that's all done in a config file. It's pretty easy. But if I put pins back on the deck, I'll just focus on the screen here while I'm doing this. I'll try at least. So I put pins back on the deck here, and if I just put them all back on. Let's see here. So if I put them all back on and we run the scoring, pretty much the scoring routine. There we go. So actually it says hit S to score the current deck. And if I zoom out a little bit, that'll probably help. So we hit S on the keyboard. And it says current deck score is 0. So this allows you to kind of mess around with the positioning of the camera and everything, because it's real time. So I take one pin off, we hit S, it senses that as a 1. So it allows you to really kind of get some fine-grained control over, you know, camera positioning, thresholding, and everything like that. So it's all very basic. You know, it's either, well, it's black and white. It's actually exactly what it is, and you just mess with the threshold values to get a good number. And all you have to do is move the mouse and click wherever you want on the screen to add pretty much a calibration point, is what we call it in software. But you just kind of click it, and that adds it to the system, and if that point lies on top of a couple of white pixels whenever it decides to score, then it counts it. And it's worked really well. So hopefully, whenever I get some of the kinks worked out and get it to a good baseline, you guys can use this. This is going to be, though, the final product is going to be controlling, of course, more than just a camera. It's actually going to be controlling a full-blown system. It's going to be a long haul, though. I'm because I'm learning a lot as I go along, but it's going to be controlling, first a gate. There will be a rake assembly, and it'll be modeled after the 8270 sweep, much like Andy's is. And it will be controlled by the computer. So that type of development there will be very basic mechanics, but it's going to be controlled by the computer. And the computer is going to go through... what I'm using as an interface board is actually a microcontroller called the Arduino, and a lot of you have probably heard of it, but this is the Arduino Mega. And it's got a couple of cool features. I mean, it's only a 16 megahertz processor, so it'll be just doing the basic motor control, and it'll be interfacing with our opto sensors and things like that. So 16 megahertz processor, but we've got 54 digital I/O pins and 16 analog input pins. So there's a lot that we can do with that. For the most part, it'll just be controlling banks of relays that go to motors, like our windshield wiper motor, which will be controlling our sweep assembly. But it's got 128K flash, so there'll be plenty of room on here for our program to control all these motors. And so how it'll work in the end is our Python software will connect to this through USB interface. Actually, there's a USB port right there. And it will send instructions to this to either turn the motors or read the switches and things like that. So we'll be probably going interfacing to those motors through sets of MOSFETs and relays. So and it's really cool because it operates on a wide voltage, like 6 to 20 volts DC. So it'll be powered off of our 12-volt rail going into the machine. So very cool stuff going on there. And I will definitely update you guys more as it goes along. So next I'm going to take this apart, move it back up into the garage, and start on the sweep assembly, and just more to come. If you have any other questions, though, feel free to comment or go to the thread. I've got a thread going over there at Bulltech. Comment, like, subscribe, all that stuff. So if you have any questions, let me know. Thanks.